Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 4, Lesson 2. We're going to talk about parallelograms. A parallelogram is a type of quadrilateral. It has 4 sides, and you can see a picture of it here on this page. The definition of a parallelogram goes like this. A parallelogram is a quadrilateral with 2 pairs of parallel sides. A parallelogram is a quadrilateral with 2 pairs of parallel sides. Now you can notice on this picture that there's 2 sets of arrows. BC and AD have single arrows, and AB and DC have double arrows. So we have, remember those arrows mean that the sides are parallel. So we have 2 sets of parallel sides. Parallelograms have many properties, and here's the first one. If a quadrilateral is a parallelogram, then opposite legs are congruent. I'll just put the symbol there, but I'll write it under here so you remember what that symbol means. Basically means equal. So when you look at this picture, see how opposite sides have the same number of tick marks? Like for instance, right here, J, K, and ML each have 1 tick mark. They're congruent. And then J, M, and KL each have 2 tick marks, so they're congruent. Also, it goes the other way. If you see a quadrilateral that has opposite pairs of sides congruent, then you also know it's a parallelogram. So it kind of goes both ways. A second property of parallelograms is opposite angles are congruent. And so you can see over here on the right, we have a parallelogram. J and L each have 1 curve, so they're congruent, and K and M each have 2 curves, so they're congruent. And actually the converse, or the opposite, is also true, because if all you saw was a picture like this where the 4 angles were marked and opposite angles of the quadrilateral were congruent, then that would be enough information to know, oh, that's a parallelogram. Another property. If a quadrilateral is a parallelogram, then consecutive angles are, they're supplementary, which means they add up to 180. So let's write 180, and then underneath let's write supplementary. This was a word we learned a couple chapters ago. So what I want you to look at is like angle J and angle M. See how those are consecutive angles. They're right next to each other. They're not opposite of each other like J and L. J and M are consecutive, and those 2 angles would add up to 180 degrees. Let's try number 1. So if we want to find X and Y so that this figure is a parallelogram, well, one of the things we know if it's a parallelogram is opposite sides are congruent. And so I'm looking at the sides here, and I notice right here we have a 4x minus 2y, and that should be equal to the 2. But since there's an x and a y in there, it's going to be kind of hard to solve for that. So I'm going to wait on that. Let's look instead at the top and the bottom. So I think we can start here. We can say 6x plus 3 equals the 15, because opposite sides in a parallelogram are congruent. So think about how would you solve this for x. Minus the 3, so 6x equals 12. Divide by 6, x equals 2. Now, the next thing we have to do is we have to use that 2, and we're going to plug it in right here for the x, because x equals 2. So we're going to say 4 times 2 minus 2y. Instead of 4x minus 2y, we're going to plug in the 2. And that equals the one across from it, which is over here, which is 2. There's a lot of 2's here. 4 times 2 is 8, so 8 minus 2y equals 2. Subtract 8. Negative 2y, this is strange, we get negative 6. But divide by negative 2, A negative divided by a negative will be a positive, so that will be positive 3. So x equals 2, y equals 3. Let's try number 2. Find the values of x and y so that the figure is a parallelogram. Well, if it's a parallelogram, I know opposite angles are congruent. So A and C are opposite angles. They should be equal to each other or congruent. So y plus 10 should equal 2y minus 40. Subtract y. 10 equals y minus 40. Add your 40. And I think we get 50 equals y. Now we have to find x. And the reason I didn't start with x is because there's nothing at D, and so I couldn't really set opposite angles equal. Instead, I'm going to use A and B. Now those are consecutive angles, so they should add up to something. They're not equal to each other, A and B, but they do add up to 180. And so what I'm going to need to do is use the y. We have y equals 50. Plug that in. So it's going to be 50 plus 10 plus the 4x equal 180. So corners A and B added together equal 180. And you plug in your 50 for the y. So we have 60 plus 4x equals 180 minus your 60. You have 4x equals 120. Divide by 4. X equals 30. Please pause the video and try number 3. See if you can solve it for x. I decided to use J and L. They're opposites of each other. They're across from each other, so they should be equal. So the 2x minus 1 should equal 75. You don't have to use M if you don't want to in this situation. So I added 1 to each side. So 2x equals 76. Divide by 2. And x equals 38. So just remember, opposite corners are congruent. Next, if a quadrilateral is a parallelogram, then diagonals bisect each other. So first we need to know what a diagonal is. From J to L, this green highlighted line is a diagonal. From M to K, there's another diagonal. So the green and red diagonals are marked. Now, what this theorem says is that if we have a quadrilateral, they bisect each other. So this distance and this distance are equal. And then also this distance and this distance are equal. Bisect means that they get cut in half. The converse is also true. If you saw a shape that looks like this, where you have something that looks like it might be a parallelogram, and then these two are equal and these two are equal, that is enough to know, oh yeah, that's a parallelogram because the diagonals bisect each other. So using that idea, let's do number 4. Find the value of C for the figure to be a parallelogram. Well, if this is a parallelogram, these two parts of that diagonal would be congruent. So 3z minus 4 would equal z plus 5. Then you have to solve it, so I would probably go minus z. So 2z minus 4 equals 5. Add your 4. 2z equals 9. And then divide by 2. Now we're going to get a decimal. I believe it is 4.5. And there's no label, so we don't have to worry about that. Please pause the video and try number 5. You're going to try to solve for x, y, and z, all 3 of them. So for x, I'm going to use the 5x and the 27. Opposite sides are congruent. So 5x will equal the 27. Divide by 5. And x equals, it's a decimal, 5.4. Next, I'm going to try to solve for y. So y plus 4 is here on this diagonal, and 2y minus 5 is on the other part of that diagonal. So they should be congruent if it's a parallelogram. So y plus 4 should equal 2y minus 5. Minus your y, 4 equals y minus 5. Add your 5, 9 equals y. And then last but not least, we have the z, and I think this is the hardest one to see. So the 33 and the 3z are equal to each other. And you might be like, why? Well, look at this line QR and this line TS. And then QS is the transversal. The 33 and the 3z are alternate interior angles. And if the lines are parallel, they are congruent. They're the same size. And they are parallel, the lines are parallel because it's a parallelogram. So what we can do is we can say 3z equals 33. Divide by 3, z equals 11. There is one last property for parallelograms. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So you can see on here that this side and this side are both parallel because they have the arrows, and congruent because they have the tick marks. And so because they have both of those, then this is enough information to say, oh yeah, that's a parallelogram. It has one pair of sides that is both parallel and congruent. So, next part, you're going to be given some quadrilaterals, and you have to figure out, is there enough information there to know if it's a parallelogram? There are 5 things that could happen that would make it a parallelogram. Thing number 1 is you might have 2 pairs of opposite sides parallel. So for number 1, it would look like this. You have something where this is parallel to that, and the left is parallel to the right. If you saw that, you'd be like, yep, parallelogram. Number 2 is opposite sides are congruent. So number 2 is you might have something where these are equal and these are equal. That is enough to say that it's a parallelogram. Number 3 is you might have something where opposite angles are the same size. That's enough to say it's a parallelogram. Number 4 is you might have diagonals that bisect each other. So cut each other in half. And then the last one is you might have one pair of sides that is parallel and congruent on the same pair of sides. So take a look at number 7. Do you think there's enough information there to know if it's a parallelogram? If you're thinking yes, you're right, because the 12s are equal and the 5s are equal. So we have 2 pairs of congruent sides. How about number 8? Do you think there's enough information to know if it's a parallelogram? The answer is not enough info. Because I only have one pair of congruent sides and one pair of congruent angles, and I need 2. I need either 2 sides or 2 sets of sides or 2 sets of angles. Number 9, what do you think? Is there enough info there? The answer is yes. It's like number 5 up above here. You have one pair of sides that is both parallel and congruent. So since the 3s and the arrows are on the same sets of sides, that is a parallelogram. How about number 10? Number 10, there is not enough info. We only have one pair of congruent sides, and we need 2, so not enough info. So now I would like you guys to try Unit 4, Practice 2. If you have questions, just send me a Schoology message. I'll help you out. Have a great day.